Now, no, I want to put that in comparison. Notice that in finding must-fix bugs, we delivered a net reduction in cost of quality of over $500,000, and for the non-must-fix, the value is only $32,500. So it's an entire order of magnitude less, more than an order of magnitude less. So, clearly focus on finding the must-fix bugs. The non-must-fix bugs are kind of, in a sense, almost loose change picked up off the table relative to the real hard value of the must-fix bugs. But there's more, as television ads used to say. But wait, there's more. So far, we've just been looking at the cost of cost associated with finding bugs. Now, the thing is that the testing is not just about finding bugs. Testing is also, in a sense, a form of insurance. It reduces something that risk management refers to as the cost of exposure. Specifically, it manages the risks associated with quality, which often do have financial consequences. So you think about, there's this economic concept of substitution. For those of you who plodded through some economics courses in college like I did, it says that one way to quantify the value of something that's perhaps difficult to quantify is to look at the value of something else that serves as a substitute for it and see if you can quantify that. So basically, insurance is the more typical way of managing risk in the real world, and one which is subjected to the free market, and thus, it's very well established as to how one puts a value on insurance. So the way that the insurance companies establish what the price is that they need to charge for a insurance policy, which you could say is the actual value of it, right? The actual price charged, which would be above that, would be their profits. The way that the insurance companies do this is through the use of what's called an expected payout. The expected payout is calculated by taking the probability of a loss and multiplying it times the cost of that loss. So let's say that you're selling car insurance and you know that 10% of your policy holders will have a claim in a year, and that the average claim will be $2,500. So you have to charge each policy holder at least $250 to meet your expected payout. So that's the break-even point for the insurance company. If they charge less than that, they'll lose money. If they charge more than that, they should make money, barring some sort of widespread catastrophe that causes a large number of people to have accidents all at once. So, given this concept of substitution, let's return back to our hypothetical case study here. And we can say, all right, let's suppose that we can estimate some average losses and likelihoods based on some studies of similar organizations. So you say, all right, there's performance problems, we're testing for performance, and organizations like ours, when they have performance problems, they suffer a $100,000 average loss and a 10% likelihood. Functional problems, and you say, that's $5,000 the average loss at a 50% likelihood. Security problems, $250,000, average loss of 5% likelihood. Other kinds of problems, a $10,000 average loss at a 10% likelihood. These are just made-up numbers to illustrate the concept here. So the expected payouts then would be 0.1 times 100,000. That's the expected payout for performance problems. 0.5 times 250,000. That's expected payout for security. You got 0.05 times 10,000. That's the expected payouts for functional and so forth. So we come up with 26,000 as our value. Now, I just want to, this is hypothetical, of course, and I want to point out, that Your average costs and likelihoods are things that you're going to probably pull off the internet and do some research on. It's based on a pretty small sample of projects. And so, this is not a high confidence number. This is really kind of a finger in the air estimate of this. Also, some organizations are less risk averse than others. Some small aggressive startups often are like, well, from great risks come great rewards. So they might not really be terribly concerned about this particular value, more concerned about the bug finding value. I also want to point out that unlike insurance, testers are not going to make the project team whole. Basically, the difference in insurance is a form of risk mitigation or risk management by transference. You're transferring the costs of a problem onto somebody else who agrees to accept it. Testing manages risk through mitigation, basically by taking steps prior to release that are going to reduce the likelihood and or impact of problems after release. So it's a different kind of risk mitigation, but it's still risk mitigation nonetheless. Okay. So again, this is no increased investment here because this testing is already happening. So we're still at an $82,500. So we say that there's basically an additional $26,000 worth of quote-unquote insurance value here, which I've shown here. And so I'm going to add that along with the $32,500 as the benefit. And so again, notice that relatively speaking, this insurance value, the risk mitigation is pretty small relative to the defect detecting value. So that was true also of the non-must-fix bugs that were found. Notice that the contribution was pretty small. And this actually has an important practical lesson for you. One of the things that you might want to do if you're going to go off and quantify the value of your testing is you might want to just use cost of quality rather than trying to do this, calculate some of these other values, because they are going to be relatively smaller contributors, and they are also, the techniques for measuring the value is less well established, so it might damage the credibility of your business case. So, be aware of these things, and you can certainly mention them as values, but I'd say that probably if you're going to just try to take a real simple approach, just focus on measuring the cost of quality and leave it at that, and just mention that these other things are also there. But since we're on this topic, let's look at the last of the four things that I mentioned, measurable value, which is the testing information as a guide to project success. So going back to our friend Capers-Jones here, estimating software costs, he identifies poor project tracking as one of the key causes of project failure. So certainly accurate, credible, timely testing metrics would be part of good project information tracking. So if you say medium-sized project, according to Jones's figures, good project tracking will reduce the risk of project failure from 40% to 20%. Assuming the testing is kind of half of the project management information picture, then you can say, okay, 10% of that is the value to the project from testing itself. So let's take a look at what that would mean. Now,